In this example, we are going to talk about drift velocity. The objective is to find how fast these electrons move inside the wire. We have an example of wire, this wire. It carries 5 amps. The current is 5 amps. And we want to know how fast the electron move inside this wire. This A is cross-section area, and the objective is to find the magnitude of this drift velocity. The definition of the current I is given by dq dt is the amount of charge per unit of time moves through the wire, which is the number of free electrons times the magnitude of the charge times the cross-section area times the drift velocity. N is the number of electrons per unit of volume is 8.4 times 10 to 28 per cubic meter. This is the number of free electrons per unit of volume for the copper wire. The cross-section area A is pi r squared. We said the diameter of the wire is 3 millimeters. So the radius will be 1.5 millimeters. The magnitude of velocity is given by the current I divided by the number of free electrons per unit of volume times the magnitude of charge. The magnitude of the charge of electron is 1.6 times 10 to negative 19 coulomb. The cross-section area of the wire is pi r squared. So this, the current we said is 5 amps. The number of electrons is 8.4 times 10 to 28 per cubic meter. Q we said is 1.6 times 10 to negative 19 coulomb times pi times 1.5 millimeter, which is 1.5 times 10 to negative 3 meters squared. We have 5 amps, which is 5 coulombs per second. Coulombs goes with coulombs. We have here cubic meter and square meter here. The square meter vanishes with a cube. We have left 1 meter here. We have 1 over 1 over 1 meter. It will be just meter upstairs. And the second here goes down here. So the unit will be meters per second. The magnitude of velocity or the speed of this electron inside this wire will be 0.165 times 10 to negative 3 meters per second or 0.165 millimeter per second. So the question is, why we have very low speed, 0.165 millimeter per second? When we turn the switch on, the light comes automatically on because of the wire, a copper wire is fully charged, and these charges are free to move. Once we turn the switch on, automatically we are creating a difference of potential. Means we are creating higher potential and lower potential. So the electron will start moving instantaneously to the higher potential. So once they move instantaneously, the motion, it creates this instantaneous light once we turn the switch on. So the wire is fully charged. By applying the difference of potential, the electron, they will start moving with the same speed. In this case, it's 0.65 millimeter per second, and they push each other to the higher potential, and this is what we get light instantaneously.